Good morning, good afternoon, or good evening, everybody, and welcome to today's webinar, Intelligent Sample Management, Combining Cellario OS and Mosaic by Cenevo to Realize Laboratory Efficiencies. My name is Mila Lay, and I'm the Scientific Marketing Manager here at HighRes. Thank you for taking the time to join us today. Before we begin, a few housekeeping items. This session will last approximately an hour. We'll have a dedicated Q&A session at the end, but feel free to submit your questions using the Q&A function throughout the program. This webinar is being recorded and will be shared with all registered attendees by end of day today. All right. Today's webinar is a collaboration between HighRes and our software partners at Cenevo, two companies at the forefront of laboratory orchestration and integration solutions. We're excited to bring you insights from our combined expertise in helping research teams streamline workflows, enhance precision, and accelerate discovery through connected systems. At HighRes, our work is grounded in a simple but ambitious commitment. We partner with life science organizations to implement intelligent data and lab automation workflows that empower every team member to plan and execute efficient and reproducible science. That commitment comes to life through three things that we hold ourselves to every day: innovation, accessibility, and reliability. Science doesn't stand still, and neither do we. HighRes combines cutting-edge robotics with intelligent software to fundamentally change how labs operate, from AI-augmented co-pilots that guide scientists through complex workflows to fully autonomous robots that execute them. We're not building the lab of the future. We're delivering it today. Powerful automation should never be out of reach. We believe that regardless of your lab size, budget, or technical expertise, intelligent workflows should be within your grasp. That's why HighRes offers flexible solutions from plug-and-play systems to open APIs, so your team can start small, see results quickly, and scale with confidence. And when it matters most, you need a partner that you can count on. With over 20 years of experience powering high-throughput laboratories, HighRes has built a reputation for uptime, precision, and reproducibility. Our products are engineered to perform and backed by best-in-class customer success teams who are invested in your outcomes. These aren't just words on a slide. They reflect how we show up for every scientist, every team, and every organization that we serve. All right, now the fun part. Let's introduce our speakers for today. First, we have Russell Green and Crystal McKinnon from HighRes. Russell is a career-long life science automation advocate who has been in the industry since his PhD in structural molecular biology. He has worked across hardware and software providers into the space, both commercially and developing product for liquid handlers, integrated systems, orchestration, and complex experimental management software, and the application of these tools to anything from genomics through synthetic biology to drug discovery. Crystal is a lab scientist turned product manager at HighRes. She has worked for 14 years in drug discovery research, automating early assay design, high-throughput screens, in vitro pharmacology assays, and compound management workflows, and has recently joined HighRes as a product manager to continue to bring the scientific perspective to the solutions being created for our customers. Finally, we have Alan Parkin from Cenevo. Alan joined Titian in 2000 and is currently VP of Product for Mosaic, responsible for guiding the roadmap for the industry standard platform for multimodal sample management. Alan has been involved in software for the pharmaceutical and biotechnology industries for more than 25 years and has managed Mosaic deployments for many of the top 20 pharmaceutical companies. With that said, Russ, would you like to give us a brief overview of the challenge that we're solving today?
Yeah, thanks, Nina. Thanks for the introduction. Yeah, before we go into some of the platform details from myself and Alan, and then a demo with Crystal, I would like to just talk you through how we perceive some of the reasons for us working together with such a tight partnership, and some of the challenges that are presenting themselves as potential blockers to sample management labs reaching their full efficiency. I've clustered these into three main areas. we often see fragmented handovers. So that might be anything from a manual transition to a bespoke or brittle tool that's been implemented to cover a constant piece of manual data handling. But what, of course, we constantly see is that when you implement those kinds of manual transitions from your sample management software through to how you're going to execute in the laboratory through instruments or integrated systems, those steps can introduce gaps in provenance of data. And even in a worst case, as we move towards this ambition of a more closed loop experimental state, we start losing really valuable metadata. And that metadata around what we intended to do versus what was executed is absolutely critical to training those AI models on how to best execute experiments in the future. We also see real challenges about understanding what our single source of truth is. We know it should be the sample management software. However, what we tend to see is that that data gets translated into planning spreadsheets or transfer lists or data that exists on instruments that never gets moved from somewhere else. And you end up with small discrepancies that build up into a big problem over time and huge traceability issues on sample provenance, understanding exactly what decisions should be made, and worst case scenario, audit trails later on down the pipeline. Probably the biggest challenge we see is that more and more labs are having to scale their workload. We see sample management facilities taking on not just larger libraries of what they've worked on to date, maybe larger compound libraries, but having to span breadths of different kinds of samples through small molecule through to large molecule and beyond. And this, of course, knocks on to a scaling amount of workload. So hundreds, if not thousands, of concurrent requests coming through that have to be managed through multiple instruments and may have shifting priorities. And to solve this properly, you need to have some kind of intelligent scheduling or orchestration platform to help handle those queues, understand how to drive decision making into real actions in the laboratory, and really claw back against some of those throughput challenges to drive that scale. So Cellario OS, when integrated with Mosaic by Cenevo, changes everything. We can start building on that absolute data continuity. So data is transferred all the way down from the request in Mosaic right through into the platform and then back. And this gives us complete data from job submission right through to execution. And of course, with that push down into the actual lab onto an integrated system, we then also build resilience against any network failures that might happen between the cloud platform and the physical platform. We also drive closed loop execution. So what do I mean by that? I mean that everything from the request through to execution back to result it can be handled as a standalone automated process. You'll see when we go into the demo, we built in some manual steps to help with the planning process, but largely that transmission of data to and fro is completely automated, and there are now no manual steps in file handling through that process. And with all of that, we ultimately deliver complete traceability, and not just traceability in those transfer files or those requests and the fact that the order's been completed, but all of that extra metadata that could be stored around what was intended to happen and what did actually happen. And you'll see this happening at quite a granular level when we start looking at those individual transfers that we can track with a device like an Echo and how that gets reported back through the platform. I would like to spend a couple of moments just talking about Cellario OS and the architecture we built. You'll see if we look on the top left of this diagram, we have three different sort of schematics of the representation of laboratories as we perceive them at HighRes. Then we have first at the top a fully automated laboratory just running integrated platforms. And at the bottom of that stack, we have the manual lab on the left-hand side, which is just running standalone devices. This is to be able to execute on a complete workflow. With this standalone device space, we were able to, with Cellario OS, control those devices directly. So this is direct bidirectional communication with devices through our 500 plus driver portfolio, pushing down instructions, gathering scientific data and process data back into the platform. If we're running systems through our integrated platform, then of course we're integrating with Cellario Scheduler. This is the tool that we use for driving those integrated systems and executing those full integrated processes. Both of those connect upwards into the Cellario OS platform, which is our cloud-based orchestration layer. So I like to think of Cellario OS as really being the interface between our digital ecosystem and our physical execution layer, translating scientific intent into fully executable experimental digitized workflows. Cellario OS itself comprises of its own data store and then 4 main core areas of functionality. We have the request function, which is the one that we'll talk about largely today, where orders can be pushed into the platform or requested in the platform against a predefined experimental workflow. A workflow itself is a fully digitized experimental chain of events that can incorporate direct device control, human operation tasks, scripts, logic statements, even protocols that run on schedulers. We have our insight layer, which is largely there to look at operational data, so how well are my systems performing? And we have our connect layer, which of course is fundamental today to connecting into our partners in the digital ecosystem, such as Mosaic. And all of this in our platform, in fact, this is true for scheduler as well, but when we think about OS, every single function has been developed API first, so that everything that you see in the UI can be called upon through a RESTful API. When we take this forward and we translate that into what we're actually looking at today for sample-driven laboratories, we see all of those different orders unified under one platform through the orchestration layer. So Cellario OS connects your sample management platform through into the systems and devices that are running in the laboratory, allowing for full real-time sample tracking. So every single sample transfer that we request to be made, and obviously this does depend on the pipetting technology we're using for how much granularity we get here. But if you think about a device like an Echo, where we get back a lot of real-time sample transfer data, this is tracked both at the plate and the well level, and it is flowed back into Mosaic. We also use Cellario OS for intelligent workflow selection. So what I mean by this is that when we get different kinds of requests coming through the platform, for example, a cherry pick versus a dose response curve setup, we're able to allocate the right workflow in the platform to be able to execute upon that in the right way and absorb those parameters that are given to us by Mosaic and translate that into something we can execute in the laboratory. And so with all of that in mind, I'll hand back to you, Neela.
That was a great foundation for understanding both the challenges and opportunities in modern sample management automation. Now, let's get a deep dive of Mosaic. Alan, take it away.
Thank you, Neela, and thank you, Russell, for the introduction. Thanks for the invitation to participate. It's a real pleasure to be here with everyone. I'm going to assume that some people in the room are not so familiar with Cenevo and Mosaic, so indulge me while I tell you a little bit about us. So Cenevo is a technology provider enabling agentic connected labs. We were formed by the merger of Titian, which is where I've hailed from for many years, and LabGuru back in 2024. So Mosaic is focused on samples. It's a sample-centric solution, and I'll tell you more about it in a moment, whereas LabGuru is more experiment-centric. I won't read out all of these stats here. I might just call your attention to this one. We work with most of the top biopharma, and indeed, for most of those ones that we work with, we have an existing integration deployed with HighRes. Okay, so I'll just tell you a little bit about the architecture of our products at Cenevo. So this shows the main components. In blue, you have a Mosaic down here showing its key capabilities, more to come. And in the purple, you have LabGuru. Both of our products have a full and extensive suite of REST APIs following FAIR principles, and both also have customer portals to extend usage to our customers' own customers. And at the top here, you can't fail to notice our new AI platform that we're working on. Consists of a number of agents to streamline workflows, and also a data layer with best-in-class analytics in the products. I won't dwell too much on this now. Well, let's talk a bit more about Mosaic specifically. What does Mosaic do to support the connected lab? So this one slider tells you about the three main things, I think. So we provide full sample tracking with a fully compliant audit trail. You can always find your stuff. We integrate and connect with all the devices you typically need in a sample management lab and workflow, as well as upstream and downstream enterprise systems. And we provide a simple interface for scientists to place requests for samples or for automated systems to place requests. All the processing required is managed in a Mosaic workflow, fulfilled typically by a sample management team. To drill more into that scenario, so imagine a scientist running a particular assay. They've determined they want to test a particular set of substances, and they'd like to do that in a particular format, dilution series, volume, concentration controls, etc. They will typically submit an order through our user interface. Step 2, Mosaic runs an availability check of its own sample stock inventory and places a reservation on the selected samples to avoid any conflicts with downstream orders. Step 3, we will auto-generate a sequence of workflow steps that need to happen in the sample management lab. And that's based on what instruments are configured in the system, their constraints, and the outputs that have been requested. And step 4 will be, in fact, a number of steps, which is the physical fulfillment. Sample bank operators are guided to fulfill the various steps, initiating runs on pieces of equipment, interacting with stores and so on. And step 5, the plates are sent out to the scientists, they get an email, etc. And just to highlight some of the obvious benefits that we'll be banging on about a lot in this webinar, automatic data capture, reduction of manual errors, reduction in cycle time. That's what it's all about. Okay, I just wanted to talk a little bit more about the integrations and lab orchestration. So to quote a very nice HighRes blog you see over here, lab orchestration is about creating seamless workflows that integrate instruments, data, people, and processes in a unified system. I hope you're all saying that together with me. What does that mean for our customers? We have over 150 deep integrations with devices that involve in sample management. So going through the loop here, various automated and manual stores. We integrate a number of rack scanners, analytical balances, benchtop liquid handlers that might be used for solubilization, cherry picking, high throughput robotic work cells such as those that Cellario OS integrates, more to come there, and smaller devices such as label printers. But in all of these cases, the common theme is the seamless handoff of instructions to the instrument based on the high level workflow, and the reporting back and ingestion of data back from the instrument. And we've invested lots of effort over the many years working with the full API offerings of these devices so we can drive them to do exactly what is required. We're not just reading back simple file data. We do that as well, but we have deep integrations. Okay. Let's go into more about how we integrate with liquid handling work cells, such as those orchestrated by HighRes Cellario OS. We have a module within Mosaic called Machine Fulfillment, and this works based on requests that have been placed in Mosaic and provides a REST API to vendors such as HighRes. Vendors can build an integration driver that will pull down details of required liquid transfers from our API, and will typically integrate with the pre-existing scheduler that actually drives the work cell. And as the sample processing happens, results will be streamed back up to Mosaic to reflect the changes in our sample tracking database, our audit trail, and also to progress the output items onto whatever the next step is in the physical workflow. I'm not man enough to do a live demo. Crystal will be doing this for you shortly, and you'll see all these steps. Okay, so next we just wanted to give you a sneak preview into an industry survey that we've conducted recently. The full data will be made available in the next few days, so keep an eye on your LinkedIn feed for that. So firstly, we asked which processes would benefit most from greater automation and tracking. You can see the top two answers here. Number one, receiving, registering, and storing samples. So this really talks to where our two systems meet, Mosaic and Cellario OS. Mosaic owns the sample identity, location, chain of custody. HighRes does the physical handling, storage, etc. And when integrated, you really reap the benefits. Number two, data analysis and cleanup. So this is where our integration really pays off downstream. So because we have this tight integration, the data, the results come back in the right structure, linked to the right sample with no manual transcription, no data cleanup, or the data is accurate for whatever downstream analysis you want to do. So if the previous slide talked about what labs want to automate, this slide and this question from our survey showed about why they can't get value from data today. Again, it's just some of the top answers, but they all speak to integration problems. So number one, lack of integration between systems. We're very obviously filling that gap. And so rather than sort of having a loose bolting together of a LIMS instrument control software, we've really worked hard together to create one connected platform. So scheduling, execution, data capture all happen in a single flow without disconnection. The second two tied for second place answers. They're again symptoms of a common disconnect. So again, just to repeat, with our two products linked together, results land in the right place in a consistent structure. Data is not stranded on individual instruments, it's flowing from the instruments through Cellario OS and back to Mosaic. Thank you.
Okay, now that we're equipped and we got a deep dive of Mosaic, let's go ahead and move to the portion of the program where Crystal will take us through the live demo. Crystal, the floor is yours.
Thank you, thank you. And I love that you commented, Alan, that you were not necessarily brave enough to do a live demo yourself. Thanks for leaving that to me. So we are starting off in this demo with the assumption that somebody, whether that's me or whether that's somebody else in my lab, has placed an order for samples. So I'm here in Mosaic. And so we're assuming that somebody has said, hey, we really need these specific samples run. And we are going to kick that off from Mosaic, and we're going to send it straight to Cellario OS, which we will then coordinate and schedule onto an actual system, and I can show you what that all looks like. So here in Mosaic, I am assuming that I'm going to focus on first my very high priority order for cherry picking on this system. So everything in here, all of the fields are sortable. So we have tube orders, plate orders, we have comments where you can be a little bit more specific about what you were trying to run. And I specifically today are trying to do this cherry picking order. So I'm going to select this and create a machine job. And once I create this machine job, it's going to ask me to select the machine, and this is the system that I would like to run this on. So in our case, and I think I started to say this, so this Mosaic instance is HighRes's Mosaic instance, so it can connect to all of HighRes's specific software. So now I'm choosing HighRes's version of Cellario OS here to complete this cherry pick workflow. And I'm going to hit next, and I would like to create my job. So while this is creating, it's going to create a unique identifier that is going to tell me a parameter that we can essentially carry from space to space so that we understand from every software that we're working with exactly what we're doing. So we have job 281 here, and it's ready and 0% completed. So if I head to OS now, Mosaic has already delivered all of the sample level information that I need to carry out my order. So I have OS here. So here I have my Mosaic job 281, and it's associated with this Cellario OS ID 13916. So if I'm going to pop into here, this is where I start to be able to schedule this order now onto my devices. So again, all of that sample level information has been tracked and passed. So what I need to do now is put it on the system where I would like it to go. So right now our cloud agent is doing the requesting because that's where it's coming from Mosaic. And you can see that here my source and destination information and my storage for all of these plates has already been uploaded for me. So again, Mosaic has passed that information from there to OS. I don't need to do anything to add these, but if I'd like to make any modifications, I can. I'm going to proceed here. And now in OS, we have a calendar where we're able to see all of the work that's happening on all of the systems across your lab. So I'm going to schedule this for right now, where we have a little bit of time. And it's simulated a time of 17 minutes. It's actually going to go a little bit faster than that because I didn't want to make you all stare at it this whole entire time. And I'm going to reserve this now. So once I reserve this, if I head back to my order management, I now see this 13916 or Mosaic Job 281 has a start time and end time estimated, and it's ready to run. So now I can actually head over to my system itself and kick this off and run it, and we will show you what that looks like. This is what it looks like for anybody who hasn't seen this. This is the Cellario scheduler, our software that controls all of our systems. And I'm going to refresh this. So now I see order 68, which is Mosaic Job 281, which is OS order 13916 and Mosaic cherry pick here. I'm going to start the system up. We're initializing our devices over here, and then I'm going to start this run. So this run is simulated. It's going to move faster than usual, like I mentioned, but we're going to take a look back into OS so we can track this live. So now if we head back into OS, so we have this SCI 13916, we see that our status has changed to active. And we can also see that that order ID 68, which is what I showed you as the order ID on the actual system itself, is also tracked here. So there are multiple things that are going on while this is running. So we have a liquid transfers tab here in OS that's telling us what's going on. So it says we have 75% of our plates processed, or I can select wells instead, and it says we have 92% of our wells processed. We have 0% failed wells. We have 7% of our wells to go. And here's where you can see live updates of everything that's happening step by step. So you don't need to go click back and forth on all these softwares like I'm doing. I was doing that mostly to show you all of the end-to-end information. But so we also have parameters, which you can set up yourself. So this is any information that you would like passed back and forth and associated with any of your runs. This could be order IDs. This could be, your well failure rate, any other job IDs. All of that can get tracked here in OS. And once it's completed, you can see our status is updated to finished. We can see file attachments, so the transfer list you originally used. If you were to be running any sort of data read step here, any raw data files might end up here. So all of this gets then pushed back into Mosaic. So OS is very much a one-stop shop that will collate and gather all this information for you. And then this finish step is what's going to trigger Mosaic to say, hey, everything's done. Mosaic is still receiving results. You can see we're 99% completed. Should be done in just a second. So this is without me having to click anything. All I did was head back over here. You can see that it's loading, and I will show you what it looks like after this is done, this job 281. The status is going to say that it's completed, and we can also click into the plate and click into the wells and get that well level information too. So again, all of this is happening without me needing to have any sort of information intervention where I'm clicking back and forth between anything. This is happening without the user pushing buttons. And I'm just going to go to that order, which I know was up here. One more time so we check out our results. And so we have 2 plates that were generated from here in our results. So if I am to click on these plates, it's going to show me a plate map of everything that was completed. So we have all of our samples here, and I can click into each well level of information, which is going to tell me my sample amount, the available amount, the concentration, solvent, everything that was associated with it from the beginning is then going to be associated with it at the end too. So that's my end-to-end demo. And again, I am so excited that you all bared with me while we were doing it live. And now back to you, Neela.
That was incredible and very insightful, and this integration is clearly so powerful. So before we get into the Q&A, Alan and Russ have some future directions that they'd like to share from HighRes and Cenevo. So Alan, go ahead and take it away.
Thank you again, and great job, Crystal. Thank you for that. So Continuing with the sneak peek of our industry survey, this one is a bit more forward-looking, but reinforcing the same integration message. So we asked where labs see agentic AI adding value. The top use case you can see: data analysis, interpretation, workflow automation, experiment design planning, sample and imagery management. Every one of those depends on connected systems and clean structured data, which we've just seen. And also, I think one thing to note about is this: that these use cases map onto what our integration is already doing, orchestrated workflows, managing samples, and so on. So in this case, agentic AI is not a separate future bet. It's an extension of the connected environment. So on that, yeah, so I wanted to talk about how we see Mosaic in the sort of medium-term future, as the backbone of the connected agentic lab. And this is all tied around the MCPs, Model Context Protocol APIs, that we're building Mosaic, where Mosaic will be the robust, validated background to all of your sample tracking workflows, no matter where you're interacting with them from. So you could, for example, use the same natural language instructions from any platform without switching user interface. And I'll just walk through some of these examples here. So at the top left, we've got the ability to request samples from Mosaic using natural language. This is something that we're in development on right now, and it'll be a much more pleasant user experience. Or if you like working directly in your chat client, for example, Claude, you'll be able to get Mosaic to do ad hoc work. For example, here, telling it to put some plates away. Down here, so, and this, we'll see a bit of this in a moment from Russell. Third-party vendor software such as Cellario OS will be able to make direct queries on Mosaic of inventory data, or maybe initiating new orders in Mosaic without having to necessarily transition to Mosaic. On the top here, so we're building an agentic framework within Mosaic with all the guardrails and context you'd expect. And this will allow the creation of agents by users, for example, to perform routine tasks like housekeeping tasks defined on triggers in the system. You've got a couple of examples here. And last but definitely not least, we're enabling customers' own agents to query and initiate activity in Mosaic alongside other enterprise systems such as ELNs and assay results systems. So this is where you really see the full agentic promise coming to reality. And I will now hand over to Russell.
Yeah, thanks, Alan. It's so interesting to see some of those insights coming back from the survey data and how that starts backing up some of the hypotheses that we already have about how these things might be used. Speaking of how these things might be used, I wanted to share with you a little snippet, just to maybe get your minds thinking about how this kind of interaction might work. So from the HighRes side, we launched in its beta form part of our platform called Lab Assistant, which is our natural language interface to our AI and knowledge base. And I can just show to you here through a video what this starts to look like when we integrate with something like the Mosaic MCP server. So I can start asking the simple questions like, what's possible here? And what can I do through this integration? And it will actually come back and start giving you instructions. Now, something I love about this kind of tool is that it tends to embed its own knowledge about how to guide you through the process of doing something you're maybe unfamiliar with. But what about if I wanted to do something more practical? Let's take this example where perhaps I've found a plate in the lab. I happen to already be in the OS platform, so I don't want to have to switch to another platform, but I could scan that barcode in to Lab Assistant and say, hey, I found this plate. Can you tell me its provenance and tell me everything about it? Because maybe it's somewhere where it shouldn't be and I need to get it to the right place. So here you can just see we're now delegating that question over to the Mosaic MCP server, and we can get back all of that information from that plate about where it belongs, what its provenance is, the dates it was processed, etc., etc. But we can even start going beyond that and digging even deeper. So what about if within that plate I wanted to explore a particular sample? So here's our is our destination plate that was created, and we want to explore which is in well A1. And again, we delegate that question to the Mosaic MCP server, and it starts coming back and telling us all the data about that individual well level information. And then perhaps to showcase one further idea, what happens if, and I think Alan spoke to this in his slide, I have a scenario where I know that something failed to run through the data that I have. Again, I happen to be in the OS platform. I can already start dealing with this and perhaps drive that particular sample transfer back into a list for later on. So now I'm asking the MCP agent to actively create something in Mosaic and say, can you create me a list of all of these items so that later on I can come back and allocate that into an order for processing perhaps my failed samples. So it just gives you a little bit of an idea about where we might go. I guess one last thing here, just interrogating order state in the Mosaic platform as well. Following on from that, I want to share with you a bit of a vision about where HighRes sees this direction of the lab of the future going in agentic-driven laboratories. I think we're definitely looking at this state where we start moving towards more AI-driven scientific intent. So we start with a question, then the AI reasoning or the agents that we allocate to this will start looking at literature, looking at our own internalized knowledge bases, and ultimately generate what should be an optimized experimental strategy. That might be everything from assay design through to delegation of particular instruments, perhaps even how you might iterate through that particular process. We're already seeing this next step happening with tools like Lab Assistant, where we can take that intent in whatever form it comes and start translating that into an executable workflow. So this is actually one of the main things we're already doing with Lab Assistant. This, alongside error resolution in the platform, is taking these SOPs or experimental designs and translating those into something we can actually execute in the laboratory, delegating particular instruments to particular parts of the problem space that workflow represents. And then following that, we are then starting to use similar tools for intelligent orchestration. This is very nascent right now, but even without the use of AI, we're now starting to allocate, as Crystal showed you, particular resources in the lab to solve particular order problems. And then we can guide users through all of the steps that need to be created for the human operations as well. So we can take a user through, set up this system, now have the system automatically executed by the orchestration layer at its respective time, and then ask the user to do the following steps afterwards, and on top of that, handle all of the data decisions and flows that need to happen with that. So all in all, we see these as like three main steps towards driving towards this faster, more efficient lab of the future state, and ultimately closed loop experimentation, because the outcome of this orchestrated experiment should drive back into that intent creation tool to drive the next iteration and wherever that might go. So having said all of that, we mentioned at the top of this that this is a partnership, and we have between ourselves and Cenevo a shared vision of what this connected lab should look like. And we've demonstrated to you what that practically looks like with the integration today, then have given you an indication of where this might go with agent-to-agent communication in the future. And I think that draws us to the close of the shared content we want to have today. I just want to say that as a partnership, these two companies have been absolutely brilliant to work with so far. We've built something brilliant together that is highly functional. And I'll hang back to Neela to perhaps field the question and answer session.
Thanks so much, Russ. Thanks, Alan, for that look ahead into the future. All right. Yeah, the integration delivers a unified, intelligent platform that eliminates manual data handovers, automates sample tracking, and guides users through any step in the lab and lets scientists focus on science. I'm sure our audience has plenty of questions, and I already see some coming through. We have about 15 minutes for Q&A, so let's dive in. The first question is a two-parter. Does the Cellario OS data populate the Mosaic audit trail? Also, is it possible to highlight the Cellario run ID with a hyperlink on the Mosaic order page? Crystal, would you like to take that one?
I believe so. And Alan, you might have a little bit more information here, but I believe it does. Yeah. And as far as the order IDs, if you have preferences or if there are things that are important to you, we're always looking for feedback in that realm. So if there are specific things that you want highlighted back and forth, just let us know. We can try to work on it together.
Yeah, Rob, you saw the link from Cellario back to Mosaic. The Cellario run ID is currently not passed back to Mosaic, but in theory it could be. Yeah.
All right, let's move on to the second question. How/where does create machine job and Cellario OS validate what control plates may be needed for a particular Mosaic plating order if the controls exist on plates independent from the required plates from Mosaic's workflow step? Alan, you want to take that?
I'll say this. Hi, Blaine. So it's similar to other integrations I think you'll be familiar with Mosaic. So Mosaic is aware of control plates in the database, and it knows what control identifiers are required, and it will identify those. We didn't see it in the demo because it would have been a bit more complicated, but it will tell you which control plate you need, and that information gets passed through to Cellario OS.
All right, next question that we have is, using the agentic AI, does Mosaic have the insight to schedule appropriately processing to certain available instruments to perform the required tasks or events? Crystal, do you want to take that one?
Yeah, I mean, if you're talking about the HighRes AI or the Mosaic AI rather, we're working on agent-to-agent communication, like Russ and Alan kind of both highlighted. So right now, you should be able to query back and forth from one or the other as far as what we're trying to develop. Alan, if you want to add here to on the Mosaic side afterwards, but you should be able to, like the HighRes AI is able to give you enough insight into like which instruments you might want to be using for certain workflows, and can make recommendations for you based on that. And then if you are talking from the Mosaic side, I mean, Russ or Alan, if you wanted to add to that.
I'll let Alan go first.
Yeah, so I mean, hi Rob. It's something that I know we've talked about before. In fact, we are hosting a focus group to talk exactly about this sort of thing in a few weeks, which you might want to join. So at the moment, Mosaic generally works on the principle of sort of late allocation to equipment, so it doesn't force things to particular work cells. So it's more flexible in that respect. But we do appreciate there's sometimes a need to push things to the particular systems based on schedules. Cellario OS does that very well.
Yeah, and perhaps just to follow up on that, I think just to reiterate, Rob, that these are both for both platforms, I think, that are in development and moving very, very quickly at the moment. I think when you look at the earlier phase of protocol creation, we are already in Lab Assistant fairly advanced in making decisions on which devices and resources should appropriately be allocated to a given task. And then the next area we're looking at is, or one of the next areas we're looking at is around how we most efficiently use the AI to allocate orders and put that into the calendar itself. So we can already do order generation, but then as you sort of highlight, the actual intelligence around resource allocation is a little bit more complex. That's definitely something we are coming to as we go into the second half of this year.
Awesome. All right, we have one more question so far, but we do have time for more. So if you'd like to pick our experts' brains, please feel free. This is your last chance. Okay. This question is, the OS demo showcased fulfilling a Mosaic cherry pick job, but I saw it had reformat series orders queued up on the request page. When OS processed those Mosaic order types, does OS perform the dose response calculations needed to achieve the desired output? And would it calculate required intermediate well plates? Crystal?
Yeah, so absolutely. The calculations and everything that you need done, OS is taking care of all of that, but really that information is coming from the Mosaic side as well. So you should be telling, like Mosaic should be telling OS everything it needs to do all of those things. And then it can perform the general actions that you're trying to get done. So the dose response calculations, intermediate plates, everything like that. That information is getting fed, and then OS is smart enough to say, okay, here's what you need to do next, essentially. Short answer, yes.
And just to add to that, Blaine, so actually, it can work both ways now in Mosaic. So in the Cellario OS integration, as Crystal says, Cellario OS is doing the dose response calculations, but in other less sophisticated orchestrators, they're not able to do that, and Mosaic can now do the dose response calculations and intermediate plates and send basically that full, exact, detailed set of transfers to the integration driver using the machine fulfillment module.
That was a great question to end with. Thank you to everyone who submitted questions today, and thanks for being engaged. I want to thank Alan, Crystal, and Russ for sharing your expertise with us today. This was an incredibly valuable discussion. Here's what happens next. The recording of today's webinar will be sent to all registered attendees as soon as it's ready later today, as well as a brief survey. You can also help me out by scanning the QR code on the screen now. We greatly appreciate your feedback to help us improve future webinars. If you'd like to continue the conversation or learn more about how HighRes can support your lab orchestration needs, our contact information will be included in this follow-up email, or you can email us on the email on screen. And I apologize, but we had Cenevo's email on here as well. It's not there, but keep an eye out for the follow-up email where we'll include that. So thank you all for joining us again today and for your thoughtful questions and engagement. We hope that you found this session valuable and that you can apply these insights to your own lab orchestration initiatives. Have a great rest of your day, everybody. Take care.
Thank you, everyone.
Thanks all.